Hey guys, in this lesson we're going to look at how to solve quadratic equations using several different methods. So there's a lot of ways you can do this. We're going to look at, I think, 5 different ways to solve them, depending on what you're looking at here. So, this is kind of a long lesson. Hopefully, we actually took 2 days in class to work on this, so hopefully you weren't out both of those days. But if you were, this should be able to recap everything that you need to know. So let's get into it. So quadratic equations are equations that can be written as ax squared plus bx plus c equals 0. That's the standard form of a quadratic equation. Really, a quadratic equation is any equation whose greatest exponent value on a variable is an x squared. If it goes bigger than an x squared, it's not quadratic. But if it has an x squared in it, and that's the largest it goes, it is. So that form is called standard form. When I ask you to give solutions for a quadratic, those solutions are the x-intercepts for that function, or places where it touches the x-axis. So there's some different words they'll use for that. Sometimes they'll call them zeros, and we've talked about that before. Sometimes they'll call them roots, and sometimes they'll just call them solutions. So since quadratic functions all have a greatest exponent value of 2, they all have the same shape. So the shape of a quadratic function is always U-shaped. It's a parabola. So they can either be a right side up U or an upside down U. And we've looked at some of these graphs already before, right? So if you think about it, if you had a coordinate plane and you drew one of these in the coordinate plane, it is possible for that U to touch the x-axis twice, right? But it is also possible for that U, I should have done this with something I could move, but anyway, to be drawn like this, where it would only touch once. Pretend like that goes all the way down. Or it's possible to have a U drawn up here where it doesn't touch at all. So it's possible to have 2 solutions, 1 solution, or even no solutions to a quadratic function. So we're going to look at how we can graph this, or look at a graph of it and see how many solutions it's got and what those solutions are. And then we'll look at some other methods to algebraically solve for those different types of solutions. So if you're going to solve a quadratic equation by graphing, and this is the easiest option, you can't always get exact answers with this option. So if you have something that comes out to be like a non-whole number answer, you may not be able to do graphing to get it. But if you want to try graphing first, that's always a good option to go with if they ask you to solve. And so all you're really going to do is look for where it crosses that x-axis. If it crosses the x-axis twice, there are 2 solutions. If it crosses the x-axis once, there's 1 solution. If it doesn't cross at all, there are none. But you need to know that you cannot round answers to equations. So if you get something that is a decimal, you should not use it as your answer. You need to go find another way to get an exact answer, because rounding it is going to give you a wrong answer overall. So, again, if you're graphing these things and you're trying to find the solution, you're just looking for the points where it touches the x-axis. So here's some examples. In this first one, we see that that graph touches the x-axis twice. Touches right here and right here. So the x values there are my solutions. I give my solutions as x equals whatever those numbers are, -1 and 2. Don't put parentheses around it. We don't want to talk about a point. We're looking for just the solutions, so the values that x can be. X can be -1, x can be 2. The next one doesn't touch the x-axis at all. Here's my x-axis. That graph never touches that line. So this has no solutions. And then this last one down here touches the x-axis only once. Right there at 0. So my only solution is 0. Really simple to solve these things with graphing. Now here we have some that have equations, and we're going to use Desmos to graph them and find the solutions. However, when you use Desmos on your state test, it is not going to let you graph an entire equation and get a solution for it. So to be able to see the parabola for this, you're going to have to get this thing equal to 0. We've got to get it into standard form so that you can graph just the equation part and see where it would touch your x-axis. So that means I've got to take this and move it to the other side. Since it's a positive 3b, I can just subtract it to move it. So the real equation I'm going to graph is b squared plus 2b minus 35. And now that equals 0. You don't actually graph that part. You just graph this part right here. And it's going to show you the parabola. You can find your 2 points of intersection. And so you do the same thing with this next one. You'd have to move the 15 by adding it to the other side. So I would end up with n squared plus 8n plus 15 equals 0. And that would be what I need to graph to find my solutions. And again, I would just graph this part, not the equals 0, and I would find the points where it touches the x-axis. So take a minute, pause the video, go to Desmos and graph each one of these and get your solutions, and then come back and see if you were correct in what you got. Remember, Desmos is not going to let you graph anything other than x, so change your b and your n into x's, and then graph those. And again, see where they touch your x, and then come back and see if you were correct. All right, see if you got these as your answers. -7 and +5 for the first one, and -3 and -5 for the second one. And it doesn't matter what order you write your solutions in, so it doesn't matter if you go biggest to smallest or smallest to largest or whatever. None of that makes any difference. You're just coming up with your possible x values there. All right, so graphing is the easiest option. That is your go-to. Like if you're asked to give the solutions to a quadratic, that's what you want to do every time. But if they ask you about a specific method, you need to also understand these other methods I'm going to show you. So the next method we'll look at is how to solve quadratics using square roots. So this can only be used if your quadratics are written in the form of ax squared plus or minus c equals 0. So if there's a bx term, you can't use square roots. But if there's not, then you can, and you would solve using this next method, which is really simple. So to be able to use square roots, the first thing you have to do is isolate the squared part of the equation on one side. So that means if there's something being added to it, you're going to move it. If there's something being multiplied to it, you're going to move it to the other side. Then you're going to find the square root of both sides. Now, most quadratic equations have 2 answers. And the way we end up with 2 answers is because when you find the square root of something to undo the square that is in that equation, all numbers have 2 square roots. So, like, let's take, for example, radical 25. Square root of 25 is 5, because 5 times 5 is 25. But the square root of 25 could also be -5, because -5 times -5 is also positive 25. So there are 2 square roots for every number, one positive and one negative form of that. So when you go to work these out, that's how you're going to get 2 answers. You're going to use the positive and the negative form of your square root to be able to give 2 solutions to that. Then if you need to, you're going to finish solving for x, and you're going to simplify any radical expressions that can be reduced. All right, let's go look at some examples of this. So I've given us a really simple one to start with, and then we kind of work our way through. So this first one, we have no bx term in this, so I know square roots is an option. They already have the squared part isolated. The k squared's already by itself. There's nothing attached to it, so I don't have to move anything. So the only thing I have left to do is to find the square root of both sides. The square root of k squared is k. The square root of 16 is 4, because 4 times 4 is 16. but then it's also -4. So my two solutions are 4 and -4. All right, let's look at another one. With this one, I do have to do something to get the x squared by itself, because right now it's not on its own. It's got a +8 attached to it. So I'm going to move that +8 first by subtracting it. So that gives me x squared equals 20. And then same thing, I've got the squared term alone. I'm going to square root. I'm going to get x equals. Now 20, when you find it, square root comes out to be this crazy, ugly decimal. So instead of giving it as a decimal and rounding it, because we don't want to do that, we're going to leave it as the positive square root of 20 and the negative square root of 20. Now I'm going to show you something real quick with that. We're not going to go way into detail with this kind of thing because you're really not going to see a lot of it in algebra, and you'll do more of it in geometry and algebra too. And so for the sake of time, we're not going to get really into it. But the square root of 20 is a square root that can be reduced because it has a factor that is a perfect square. 4 times 5 is 20, and 4 is perfect. So if you broke that into 4 times 5, the square root of 4 is 2. So you can change this into 2 square root 5. Because root 4 times root 5 is root 20. And that one's perfect, so it can come out of the radical and we can leave the 5. So this really, in its most proper form, would be 2 root 5 and -2 root 5. Again, though, you're not going to have to do that very often. You will do that some when you get into geometry, but for now, we won't. All right, let's look at another one. I'm trying to move over there, be zoomed in, but I'm not able to do what I want to do. Okay. Well. So for this next one, my n squared is not alone yet. I have a 2 attached to it, so I'm going to move that 2 before I do my square root. Divide the 2 off because it's attached by multiplication. So that gives me n squared equals -71. Then I'll do square roots. Not 71, 72. Just kidding. So then I'm going to square root both sides. Now, if you do the square root of -72, you're going to get something that says error, non-real answer. And the reason we get that is it is not possible to find the square root of a negative number. Negative number doesn't have a square root because there's no way to multiply the exact same number by itself and end up negative, because the only way to get a negative number is to do a positive times a negative. So this is not possible. This is no solution. If you end up with an error message like that that says non-real answer, that's what that means, no solution. All right, one more to look at. Again, I've got a situation where my x squared is not alone, so I'm going to have to move that -5. Because it's being multiplied by the x squared, I'm going to divide it. So I have x squared equals -500 divided by -5 is +100. So again, I'll square root both sides. The square root of 100 is 10, so my answers are 10 and -10. All right, rolling along. Take a minute, pause the video, and try these two, and then come back and see if you were correct in those. Look back up at the ones before it if you need some examples to try to follow. check and see if you got the same thing that I got. The first one, you just had to do square root, and you get 2 and negative 2. Second one, you had to divide the negative 2 off, then do your square root. You end up at 9 and negative 9. Minus. All right, now let's look at another method. This is solving quadratics with factoring. So this works on any quadratic that is factorable. Now, some quadratics can't be factored, but if it can be, you can use this as an option. This is usually the least preferred option of all of them, but it does work, so if you want to do this, you can. So if you are going to try to solve with factoring, the first thing you have to do is write the quadratic so it's equal to 0. So if it's not already equal to 0, you need to make it so that it is. It needs to be in standard form. Then you're going to fully factor the quadratic. It says on the right side, but it's actually going to be on the left, so there's that. So you'll have a quadratic expression on the left side. You'll fully factor that. Usually that either means taking out a GCF or doing bottoms up with a trinomial. One of those two things typically. You could also do grouping, something like that with it if you want to. Then you're going to set each of those factors equal to 0 and solve each one for x. So you have two little equations you'll solve for x. Those values are your solutions. All right. So let's look at some examples of this. In the first two examples that you see here, you've got two quadratics that are already factored. So they've already broken those up into binomials. We're just going to use those binomials to find our solutions. The bottom two are not that way. We're going to have to factor them first and then find our solutions from that. So let's look at this first one where we've already got factors. K plus 1, K minus 5. All we do if we've already got factors is take each of those factors and set it equal to 0. And then we have these little baby equations that we can solve. So to solve for K, I would just subtract 1. So K is going to equal 0 minus 1 is negative 1. To solve for K in the second one, I'll just add 5. So K is going to equal positive 5. These are my two solutions. Pretty simple when they're already factored for you. Now you'll notice with one setup like this, if they've got just a single variable, not a number in front of that variable in the factored form, the solutions are always just going to be the opposite of what's in your factor. So if your factor is positive 1 and negative 5, your solutions are negative 1 and positive 5. And that works for one like that. Now this one over here that we're about to do, there's a number in front, so it doesn't work quite that way. But we can still get a solution. We just got to take a minute and factor it. So how did I move the last one, but now I can't move this? I don't always understand this thing, if I'm being real honest about it. Okay, well, I don't know what to tell y'all. I'm trying to zoom in, failing epically. Oh, that's interesting. Okay, well, there's that. Anyway, so for this next one, we'll do the same thing. Now I can zoom in on it. That's super weird. 2m plus 3 equals 0. 4m plus 3 equals 0. So again, take both of your factors, set them each equal to 0, and solve each one. So to solve a two-step equation like this, remember, you'll subtract first. So I'll bring down my 2m negative 3, and then divide both sides by 2. So m is going to equal either negative 3 over 2 or negative 1.5. It doesn't matter how you give it. And then this one, subtract 3. Divide by 4. So m is going to equal either negative 3 over 4 or negative 0.75. Either way. Those are my two solutions. All right, let's look at a couple that we do have to factor. So those were both already factored for us. Now let's look at what happens if we do need to factor one. So this next one at the bottom on the left is not currently in standard form, nor is it factored. So we're going to get it into standard form, factor it, and then use those factors to solve. So the first thing I need to think about with this one is how to get this to be equal to 0. So this negative 2 needs to get moved to the other side. I'm going to add it. So the actual quadratic I'm going to work with is n squared minus 10n plus 24. And now that will equal 0. And that's what I needed to have happen. So this is a trinomial. We've got 3 terms, which means I'm going to factor it using bottoms up. So my magic number, 1 times 24 is 24. So remember, that means you got to think about what can you multiply to get 24 that you can add to get negative 10. And so I look at that and I think, okay, 6 times 4 is 24, 6 plus 4 is 10. So negative 6 and negative 4 would make a positive 24, but a negative 10. These are going to be my two factors. So I set each one equal to 0. And I solve them. So plus 6. Now if you remember my shortcut from before, you wouldn't even have to really write this part out, because again, if you've got a factor that has just a coefficient of 1, your solutions are going to be the opposites of what we get here. So I should have a solution of positive 6 and positive 4, which is exactly what I'm about to get. N equals 6, N equals 4. So get it in standard form, factor it, use those factors to solve. All right, one more. This one's another one that's not in standard form yet, so I'm going to move it into standard form by adding 5. So I have x 11x plus 24 equals 0. And so, again, I've got a trinomial. I'm going to use magic number, bottoms up. So 24 is my magic number, which means my factors will be x minus 3 and x minus 8. Because 8 times 3 is 24 and 8 plus 3 is 11. But I need a negative because I need a negative 11. And those will be the two that I solve. I should get x equals positive 3 and x equals positive 8. All right. Okay, take a minute, pause this video, and see if you can solve these two. And then come back when you finish and see if you are correct. Use factoring to solve them. All right, take a look and compare what you got to what I got and see if you got the same thing. If you missed this first one, maybe you messed up right here. A lot of people, when we worked this in class, made the mistake of combining negative 12 and negative 6 and not getting negative 18. So if you missed this one, maybe check that part of it and see if that maybe is what got you. Also, when you're trying to figure out what your factors are. A positive 6 and a negative 3 multiply to give negative 18, but add to give positive 3. So that's what we needed here, which gives us answers of negative 6 and 3. This one, they already had it factored, so you just had to solve each one. You could give this in fraction or decimal form for that first one, so negative 5 over 4 or negative 1.25 was fine. Second one had to be negative 1. All right, so that's into factoring. Now let's take a look at another method. All right, this next method is called completing the square. That involves creating a perfect square trinomial. Oops. And then using factoring I wrote too big. Factoring and square roots to solve it. I'm writing that smaller if y'all are wondering what in the world I'm doing. So remember that a perfect square trinomial is a trinomial that, we did this in class Monday, by the way. It's a trinomial that is written as ax squared plus bx plus c. Could be plus or minus bx plus c. And the a and the c are both perfect squares. And then the b, if you remember, had to be twice the root of a and the root of c multiplied together. So we're going to look at how to create one of these from a problem that's not currently one, so we can use the shortcut factoring method to be able to solve it. So to be able to do that, you arrange your quadratic so that the ax squared and the bx term are both on the left side, and the c term is on the right. So you're not going to have it equal to 0 anymore. You're going to move that c term to the right side so that you can complete the square to create a perfect square trinomial. Then you're going to find the value of c that will create a perfect square trinomial. Here's how we do that. You take the b and you divide it by 2. Because normally to figure out what b would have to be, you would have doubled b. So to figure out what you had to start with, you can half it instead. So divide the b by 2, then square it. Then you're going to add that value to both sides of the equation. So again, you take the b, divide it by 2, and square it to get c. C is equal to b over 2 squared. There we go. That was running together. Once you get that, you factor it. Oh, no, not factor it. I'm sorry. Solve using factoring and square roots. So remember, you can factor a perfect square trinomial into a plus or minus b squared. Or really, it's the root of a plus or minus the root of b squared. So you'll quick factor it into that, and then use square roots to finish solving what you get. All right, so let's take a look at how this works. So here I've got a trinomial that we need to solve the quadratic for. And so the first thing I want to look for to know if I can do complete the square is to make sure that my A term is a perfect square, because if it's not, I'm not going to be able to do complete the square with it, and I'm going to have to make some adjustments. So A squared is a perfect square for this, so I know that I can use complete the square to be able to solve it. So the first thing I've got to do is empty the space where C should go. So that -3 or that -3 that's right there has to move to the other side. So I'm going to subtract 3 off both sides. And that's going to give me A squared plus 2A plus, I don't know what's going to go here yet, but I'm going to figure that out, equals -3. Now, whatever I decide to add to this right side or to the left side, I also have to add it to the right, because that's the only way to keep my equation balanced. So I'm leaving myself space to be able to do that for both. Okay, so once you get the space empty, and you got to figure out what's going to go in that box. So you take your middle term, so for this it's 2A. And I'm going to start by dividing that by 2 and then squaring it. So 2 divided by 2. And then squared. 2 divided by 2 is 1. 1 squared is 1. So I'm putting 1 in the box on both sides. Once you do that, you have created a perfect square trinomial. A squared plus 2A plus 1 is a perfect square trinomial. So I'm going to quick factor it. Let me go to a new color. Remember, perfect square trinomials factor into the square root of the first term. So A squared becomes A. Square root of the last term, 1 becomes 1, because the square root of 1 is 1. It's plus because it's addition. And there's a square to the outside. And then on the other side, we're going to do -3, not -3, +3. I was like, why does that turn out negative? That's my fault. We're adding 3 on both sides, y'all. So +3 plus 1, which is 4. That's how that was supposed to turn out. And so I have A plus 1 squared equals 4. Now I have something I can solve with square roots, because I have a squared term all by itself on one side. So when we use square roots on this, we find the square root of this side and the square root of this side. So the square root of A plus 1 squared is just A plus 1. The square root of 4, if you remember when we did this earlier, is 2, but it is also -2. So I've got 2 different answers I've got to work with. And then I'm going to finish solving this just by getting A by itself. So A plus 1, I'm going to subtract 1 to get just A. Which means I'm going to subtract 1 from both of my answers over here. -1 from both. So my solutions are going to be 2 minus 1 is 1, -2 minus 1, -3. These are my 2 answers to this problem. Feels a little complicated at first. It gets better the more you do it. All right, let's look at another one. This one's already equal to 0. But remember, when we're doing complete the square, we need it not to be equal to 0. We need it to have, or we don't have to have it equal to 0. We have to have an empty space for C on the left side. So K squared is a perfect square. Complete the square is an option here. I've got to move the 12. So I'm going to subtract 12 off both sides. So I'm going to actually work with K squared plus 8K plus something equals -12 plus whatever that something is. So to find that number that goes in that box, this is maybe the hardest part of this. Not hard, but it's just easy to forget. You take your middle number, which is 8, divide it by 2, always dividing by 2, and then square it. 8 divided by 2 is 4. 4 squared is 16. So I'm adding 16 on both sides. That has created for me a perfect square trinomial over here on the left, which means I can factor that with quick factor, K plus 4. And I get K plus 4 because K squared becomes K, 16 becomes 4. And then the other side, we'll just combine -12 plus 16 and get 4. And then I'm going to finish this the same way we did the one we just did before. Find the square root. So k plus 4 will equal, the square root of 4 is 2 and negative 2. Then we finish it by subtracting the 4. That'll get k by itself. I'm actually going to switch up how I wrote that. I'm going to pull my negative 2 down here to the bottom. And subtract 4 from both. So my answers will be 2 minus 4 is negative 2. Negative 2 minus 4 is negative 6. All right, let's do a couple more of those together and then let y'all try a couple. All right, so with this next one, again, first thing we've got to do, p squared is a perfect square, so we can use complete the square to solve this, but I've got to move the 21. I have an empty space there. Oh, I might have turned my microphone on and off. Hopefully it's been on the rest of this time. So, p squared minus 8p plus something. 6 minus 21, negative 15. Now again, to figure out what goes in that box, we're going to take that middle number, 8, half it, and then square it. 8 divided by 2 is 4, 4 squared is 16. So I'm going to add 16 on both sides. That means this side can quick factor into p minus 4 squared. And look, it's subtraction this time because there was subtraction right here. But p comes from the root of p squared. 16 becomes 4 because the root of 16 is 4. And then this negative 15 plus 16 is 1. So then to finish solving that, I'm going to do square roots. And that'll give me p minus 4 equals 1 or negative 1. And I can finish solving it by adding 4 on both sides. So my two answers are 5 and 3. 1 plus 4 is 5. Negative 1 plus 4 is 3. Okay, one more. All right, with this one, we've got m squared, so we know that it is a perfect square. We can use square roots to solve. Let me move the 48. So I get m squared plus 2m equals, oh, plus something. Let me put my box. Equals 42 plus something. All right, so now to find what goes in the box, take the middle, divide it by 2, and square it. 2 divided by 2 is 1. 1 squared is 1. 1 goes in the boxes. That means this will quick factor into m plus 1. The square root of m squared is m. Square root of 1 is 1. 42 plus 1 is 43. And then we'll do square roots to solve this. Square root of m plus 1 squared is m plus 1. Now the square root of 43 is a super weird number. Like it's a irrational number. It's one of those crazy decimals. So what we do when we end up with situations like that is we're going to leave it in radical form. So I'm going to have root 43 and I'm going to have negative root 43. And then to finish solving it, we're just going to subtract 1 from both of those things. Now you don't actually do the math on that. You're going to leave that written just like that. And those are your two answers. Root 43 minus 1, negative root 43 minus 1. And that does happen that way sometimes. All right, let's let y'all try a couple of these. But I want to look at the beginning of the first one with you. So this first one is really mixed up, and it has a number in front that is not a perfect square. So before we can work this using complete the square, we've got to fix that issue. So the first thing I want to do is figure out how to get everything to the correct side it's supposed to be on. So this negative 21 is supposed to be over here. This positive 10v should be over here. So I'm going to flip that around and make it 5v squared minus 10v, because I'm going to subtract the 10v to get rid of it, plus something equals 21, because I'm going to add the 21 on this side. So I can add the 21 to get rid of it over there. I can subtract the 10v to get rid of it. Okay, so that gets it at least in the correct order. Now I got to deal with this issue of there's a number here that's not a perfect square. So because 5 is not perfect, the easiest thing to do to fix this problem is to divide the 5 off. But if I divide by 5 right here, I have to divide everything by 5. So that'll cancel that and give me v squared. 10 divided by 5 is 2v. Still have my empty box. 21 divided by 5 is 4.2. And that's fine. You can leave it like that. So now you're going to complete the square working with this. So take a minute, pause the video, complete the square with this one, and finish solving it. And then when you get done with that one, go on to the next one and complete the square with that one. The next one is a little more traditional than the first one that I gave you here. But take a few minutes, finish completing the square and solving both of these, and then come back and see if you were correct. All right, take a look at how these turned out. So the first one, when we picked it back up, we divided the middle by 2, squared it, and got 1, so I added 1 on both sides. The square root of 5.2, when I did square roots with this, so I quick factored that into v and 1. Then I did square roots on both sides, and 5.2 doesn't come out to be pretty, so I left it at 5.2 and negative 5.2. And then I just added 1 to cancel out the negative 1 that was with my v, and those would be my 2 solutions there, so we can leave them in radical form. The other one was a little bit easier, so I moved the 14 to the other side and got negative 21 over there. Filled the box with a 25 because 10 divided by 2 is 5, and 5 squared is 25. So that comes out to make m plus 5 equals 4. Square rooted all of that and got 2 and negative 2 from our roots of 4. Subtracted 5 from both and got negative 3 and negative 7. All right, moving along. So the last thing we've got to look at is how to solve quadratics using the quadratic formula. So quadratic formula works for any quadratic, and it feels complicated when you first learn it, but it does work for everything. So it is an easy go-to option if you're not sure what method to use. This one is one that you can always use. So, and the formula is complicated, but they give you the formula on the state test, so it's not a big deal if you don't necessarily know it right off the top of your head, because you're going to be given it on the state test. So what we end up doing with it is we just look in our equation, get the values that go for A, B, and C, and then we sub those into the formula and solve the formula, just like you would any other formula, like a volume formula or a circumference or area formula. You just plug the numbers in and then calculate. So first thing you got to do if you're going to use quadratic is write the equation so that it is in standard form. So if it's not in standard form, arrange it so it is. Remember, that's ax squared plus bx plus c. Then you're going to substitute the a, the b, and the c into the formula and solve. Here's the order that you want to solve it. PEMDAS would tell you to do parentheses first, but there are none. So the next thing you do is exponents. A radical is like an exponent. Okay, so when you have something in a radical, that's just like doing an exponent. So you start by solving the radical part first. Then you combine the numerators and denominators, splitting the problem into 2 fractions. And I'll show you why it's 2 in just a minute. Then divide the fractions to simplify. right, let's look at how this works. So first thing you got to do is make sure your equation is equal to 0. If it is, you should be able to look at it and be able to pick out your A, your B, and your C. A is the number in front of your squared term, B is the number in front of your single variable, C is the constant. So for this, there's an understood 1 in front of my m squared. There's a negative 5 in front of my m. There's a negative 14 for C. Those are going to be my 3 numbers that I'm going to substitute. So then we got to think about the formula. So remember, the formula is, I'm going to write it down up here. You don't have to write it back down because you've got it on your slide right before this. It's negative b plus or minus square root of b squared minus 4ac all over 2a. So I'm just going to take all these numbers and put them in place of the a's, the b's, and the c's in that formula. So negative b is negative 5. So negative b plus or minus square root negative 5b squared minus 4 times 1 times negative 14 all over 2 times 1. Now this looks really, really complicated when you just look at that formula with all those numbers and you're like, what in the world is all of this? Because it's probably what you're feeling in this moment. But take it piece by piece. So start with just the radical. So you want to calculate the value of what is in the radical. Now you can type the radical in your calculator and put all the numbers underneath it, or you can calculate the inside of the radical first and then go back and find the square root. It does not matter to me which way you do that. The thing is, though, if you do that and you get a decimal when you put the radical on it, you're going to have to go back and recalculate it without the radical so you can leave it in radical form. So I'm just going to calculate negative 5 squared minus 4 times 1 times negative 14. And when I do that, I get 81. So I know that what goes in that spot for the radical is the square root of 81. So the square root of 81 is 9. So this is going to be something that I can really easily use to finish solving this. So that means that when I go to put this down for my next step, I'll just come right here with it. Negative 5 is going to be positive 5. Because 2 negatives make a positive. Plus or minus, square root of 81 is 9. All over 2 times 1 is 2. So I've now simplified this part to become 5. I've simplified this part to become 2. And I simplified what was in red to become 9. That's where those pieces are coming from. So now all I have to do to finish this out is to actually do the calculation here. 5 plus 9 divided by 2, and 5 minus 9 divided by 2. Because the way this can go is it can be 5 plus 9 or 5 minus 9. That's why we have plus or minus in the formula. So that's how we're getting 2 answers. We're doing one with addition, one with subtraction. So 5 plus 9 is 14, divided by 2 is 7. 5 minus 9 is negative 4, divided by 2 is negative 2. Those are my 2 solutions. All right, let's go do another one. Now this next one is not quite in the right format. I've got to move the 10 so that I have something I can actually work with. So now I'm in standard form, and I can work this using quadratic formula. In that equation, my A is going to be 2, B is negative 7, C is negative 3. So I'm going back to my big formula. So my formula is over here still. I'll zoom out to write this part, and I'll go back in a minute. So with my formula, I'm going to do negative 7 plus or minus square root negative 7 squared, b squared minus 4 times 2 times negative 3 all over 2 times 2. So negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. All right, so now let's look at how we are going to go about solving this. So just like before, we're going to start by solving what's in the radical. So I'm going to do this part first. So negative 7 squared. And you do have to put that in parentheses. If you don't, you're probably going to end up with wrong answers. Minus 4 times 2 times negative 3 gives me 73. So that means what's in the radical is equal to radical 73. Now here's the thing about that. Radical 73 is not a perfect square. So it's going to give me a weird irrational number. So we don't calculate that and get a decimal. We leave it in radical form. So I'm going to simplify the other parts of this. So I'm going to simplify this negative 7. I'm going to simplify this 2 times 2. And so I end up with 7 plus or minus root 73 over 4. And since you can't simplify that root 73, we can leave our answer just like this. That represents both solutions to this problem. All right, let's go do another one. Now this one's already equal to 0. And actually these next two are exactly the same, so we're really just doing one more on this slide. So I'm going to find my A, B, and C. A, remember, is the number in front of the squared term, so that's an understood 1. B is the number with the variable, negative 4. C is the number that's constant, positive 4. So here we go again. Negative 4, negative b, plus or minus square root b squared minus 4 times a times c, all over 2 times a. Subbed everything in that I needed. Now I'm going to work what's in the radical first. Negative 4 squared minus 4 times 1 times 4. And I get 0. The square root of 0 is 0. So this is going to be a little bit different. Negative 4 becomes 4 plus or minus 0 over 2. So 4 plus 0 would give me 4 over 2. Which is 2. 4 minus 0 would also give me 4 over 2, which is 2. This one only has one solution. The only solution we can get is 2, because we have the same solution for both directions of working that. All right. So take a minute on the next slide and work those two using the same quadratic formula. Then come back and see if you were correct. Again, make sure you remember that they've got to be in standard form to be able to do quadratic formula with them. Make them equal to 0 first. Okay, take a look at that and see if you got the same answers that I got. If you missed some part of this, maybe look back and see if you subbed everything correctly in your formula. This is what I got when I worked the two radicals out, so you can kind of look at that. So this would simplify to 4. This doesn't simplify, so I left it as root 193. So that answer was able to stay just like that. This answer could kind of break itself down into the smaller pieces, and that's why I did that with those. So take a look at that and see if you got the same thing. If not, make corrections where you need to. All right. So the next 3 questions in this are test prep style questions. So I would like you to take a look at those 3. See if you can figure out answers based on what we did in this, or using Desmos maybe if you need to. But see if you can come up with answers that will work. And then come back and check all 3 and see if you were correct with those. So this one you could have just put in Desmo, so it was pretty easy. Graph each of your answer choices, see which one gave you the same equation, and this one would have, or you could have done bottoms up and factored that to get those two answers as factors. That would have worked for you. This one, you had to take your b, half it, and square it to get 64, and then add that to both sides. So you ended up with 64 here, and then you ended up with 56 on that side. So that one was also pretty simple. And then the last one is, thanks, Connor. The last one you used quadratic formula for. So you picked out your A, B, and C, subbed those in, and you ended up with C as an answer for that. So that is the end of all of that. We'll do a greater practice on this tomorrow. Y'all have a beautiful day.